All right, let's talk about, what's the first one?
Single replacement.
How do you know a single replacement? You got a single thing here, and you kind of have a pair here, don't you? And on the other side, this is definitely a pair, isn't it? It's a different pair than you had over here, and then you have a single thing again. So what happened? Sulfate got tired of hydrogen, grabbed some aluminum. What about B?
Double replacement.
Double replacement? How do you know that?
Because there's two elements.
Two
I
elements?
mean, not elements, compounds.
Two ionic compounds on the left and two ionic compounds on the right.
And they're different.
And they're different compounds. If they were the same, there'd be no reaction, right?
Right.
How do you know that silver has to go with sulfate and silver can't go with sodium? Why can't silver go with sodium? That'd be a different pair. Because they're both metals, right? And metals are what charge? Positive. Can't have two positives together, can't have two negatives together, okay? All right, what about C?
Combustion.
No. Single replacement. Look, you got a single person here. You got a pair here, don't you? What happens? Carbon takes the oxygen, runs off, and leaves iron by itself. This reaction right here actually is, anybody ever seen a steel mill on TV? You know, those big steel furnaces? That's actually one of the reactions they do in a steel furnace. Because the liquid, the red, hot, molten liquid used to come out of the bottom is iron, right? And this is how they purify the iron, other ways they purify it. What about the last one? Combustion, why is it combustion? It has CO2 and water, and it also has this guy here, doesn't it? Oxygen combining with something to make CO2 and water. So it is a combustion reaction. Okay? Five more. We'll start with something easy since we're going to do something hard later today.
Combination.
We ready? No. Shouldn't take you that long to look at these and decide. What's going on in the first one?
Combination.
Because two things come together and make one new thing, right?
Yes.
Combination. What about the second one?
Single.
Single. Silver's by itself. Grabs the sulfur. Hydrogen's left out in the cold. C?
Combustion.
Combustion. Have oxygen with an organic compound making carbon dioxide and water. D?
Double replacement.
Double replacement, right? You have a pair here, a pair here, and you have two new pairs on the right-hand side. And the last one?
Decomposition.
Decomposition. You start with only one thing, and you make two or more new things, right? Decomposition. Now, there is another class of reactions, and actually this class of reactions encompasses some of the ones we've already talked about, but it's given its own special class. They're called oxidation reduction reactions. Normally, if you hear a chemist talk about these oxidation reduction reactions, you will hear them refer to them as redox reactions. Okay? Oxidation and reduction. They involve the transfer of electrons. Okay? We've sort of learned about this process before. Remember when we talked about sodium plus chlorine going to make sodium chloride? When we first started talking about ionic compounds. We use that as an example. Anybody remember that? What's the charge on sodium on this side over here? Does it have a charge? It does not have a charge, does it? Well, it has a charge on this side, doesn't it? So if we put charges here, sodium here is 0, and here it doesn't have here it's 1 plus, right? What about chlorine over here? It doesn't have a charge either. And what is it over here?
1 negative.
1 negative. Well, in order for sodium to go from 0 to 1 plus, what did it do?
Had to gain or lose an electron.
It lost an electron, right? Remember we talked about in chapter 4 with elements in group 1 tend to lose an electron, right? And then chlorine, because it's a halogen, tends to gain an electron. Okay? That loss and gain of electrons is redox chemistry. Okay? And we're gonna give you some definitions in just a second. So, here's another example. And we'll talk about it in a second. Redox chemistry is exceptionally important. It occurs in your blood, it occurs when you digest food, it occurs when your cells expire, it occurs all the time. A lot of enzymatic processes are redox processes. The way your body makes energy through the ATP Krebs cycle, that is a redox process. Okay? All these things are redox processes. Batteries, redoxes. Iron rusting, redox. Let's look at this example right here. What's the charge on this iron right here? Does it have a charge? This iron right here. It does not, okay? What about oxygen? Does it have a charge?
No.
No. What's the charge on iron right here? Who thinks it's 3 positive? It is. Y'all should all know that. What's the charge on the oxygen there?
2 negative.
2 negative. So what happened to iron? Iron did what?
Lost 3 electrons.
Lost 3 electrons. Oxygen
Gain 2.
gained 2 electrons. Some of you may have learned this before, as Leo says grr. I don't like that. I live in South Louisiana, so I prefer oil rig. Oxidation is loss of electrons. Reduction is gain of electrons. Okay? Everybody get that? Oxidation is when you lose electrons. So if we go back, the iron here is losing electrons, so it is being oxidized. Oxygen is gaining electrons, so it is being reduced. Okay? Fair enough?
How did you decide the reactant side has 0 electrons for each?
Well, it doesn't have 0 electrons, but it hasn't gained or lost anything. It doesn't have any charge. There's no charge on these over here. This is elemental iron and elemental oxygen. That's what they look like. They don't have any charge on them. Okay? Just like in our example before, let's go back here. Sodium and chlorine, right? Sodium metal and chlorine gas. Sodium here, is sodium being oxidized or reduced? Does sodium gain or lose electrons? It loses electrons. That's how it becomes positive, right? Positive things have lost electrons. So when it lost an electron, it was oxidized or reduced? Oxidized. That means that the chlorine was reduced. Okay, they always come together. They're always in pairs. Can't have one that. You can't get money if nobody's willing to give you money, right? Your boss all of a sudden decides that He's not gonna give you any more money, you're just gonna be poor. Right?
That sucks.
That would suck. Electrons are chemical currency, right? Sodium had an electron to give up, chlorine took it. Okay? And then in this example, iron has 3 electrons it's going to give up. Oxygen's like over here. Each oxygen atom will take 2.